Okay, in Chapter 5 we're going to be looking at integration, which is essentially the inverse process of differentiation, or taking the derivative. And so it's one of the things that mathematicians always ask is, if you see a function, you ask what is the thing that undoes that function? What is the inverse of that function? And so in example 5.1 we're asked what is the inverse, or what's the rule of finding the inverse of the derivative? Okay. And we use kind of a funny notation for the inverse, or the integral function, which is the inverse of the derivative. So let me just start by saying that we know that if you take x to the n and you stick that into the derivative function, d dx, we know the rule. We know it's going to spit out n times x to the n minus 1. Right? So we multiplied by the exponent, and then we subtracted 1 from the exponent. And the question is if you were going to have a function that was going to undo the derivative, which I already said we use kind of a weird notation. It's like a squiggly line and then parentheses and then dx. That means the integral with respect to x. We know that it should undo whatever the derivative did, so it should spit out x to the n, right? And so if you think about that, it took in n times x to the n minus 1, and it spit out x to the n. So if I write this in terms of what it did to n times x to the n minus 1, I would say that it added 1 to the exponent, and then it divided by that new exponent, right? So x to the n minus 1 plus 1 would give you x to the n, and then the n over the n's would cancel. So that's how we got x to the n. And so let me put it this way. If you take x to the n and stick it into this integral function, the inverse of the derivative, the rule is going to be add 1 to the exponent and then divide by that new exponent. It's the exact opposite of the derivative, right? The derivative, you multiply by the exponent and then you subtract 1. If you reverse that process, you're going to add 1 to the exponent and then divide. Okay? And you can just check that if you stick that into the derivative function, what do you get out? Well, you're going to get n plus 1 times x to the n plus 1 minus 1 all over n plus 1. So again, the n plus 1 and the n plus 1 cancel, and the n plus 1 minus 1 becomes x to the n. Okay? So you can see here that this is essentially the inverse of the derivative function. You're just going to add 1 to the exponent and then divide by the resulting number. So let me just say that in words here. Add 1 to exponent and then divide by the new exponent. That is the rule.